Hi class, in lesson 9.5 we will be again using multiple representations to solve problems. Learning target for today, we will be using words, symbols, tables, and graphs to solve problems. Let's take a look at problem 1 on page 644 and read over the problem situation. It says that Jamie and Liliana need to measure some pictures so they can buy picture frames. They looked for something to use to measure the pictures, but they could only find a broken yardstick. The yardstick was missing the first 2.5 inches. They both thought about how to use this yardstick. Liliana said that all they had to do was measure the pictures and then subtract 2.5 inches from each measurement. So that is the problem situation that you will be thinking about as we start to answer questions in problem number 1. Go ahead and answer number 1 through number 5 on page 644. Again, just like we did in lesson 9.4, I'm going to give you the variables to work with so that we all have the same ones. M is going to be equal to the measurement with the broken yardstick, and N is going to be equal to the actual measurement. So go ahead and do number 1 through number 5 on page 644. If we take a look at number 1, yes, Liliana is correct because the yardstick starts at 2.5 inches. For number 2, the length would actually be 11 minus the 2.5, so that would be equal to 8.5 inches. For number 3, the width is actually going to be 7 inches because we're going to subtract 2.5 from 9.5. I gave you the variables that we were going to use for number 4. M is equal to the measurement with the broken yardstick, and N is going to be equal to the actual measurement. The equation then that is going to model the relationship between these variables will be M minus 2.5 is equal to N. If we take a look at number 6 on page 645, it says to use the equation M minus 2.5 is equal to N in order to calculate the actual measurement if the measurement taken with the broken yardstick is 25 3/4 for letter A, 21 inches for letter B, and 18 5/8 inches for letter C. So go ahead and do A through C for number 6. For letters A through C, we are taking each of the values and substituting it in for the variable M, since it is the measure of the broken yardstick. When you do that, you will find the actual measurement then for each. For letter A, you're going to have 23 1/4 inches. For letter B, the actual measurement is going to be 18.5 inches. And for letter C, the actual measurement is going to be 16 1/8 inches. If we take a look at number 7 on page 646, we again are using our equation M minus 2.5 is equal to N in order to calculate the measurement taken with the broken yardstick if we are given the actual measurement. Again, we want to then check our solution using the original equation. So go ahead and do letters A through C for number 7. For each of the values that we are given in number 7, they are going to represent the variable N, which is the actual measurement. When we use an inverse operation in order to try to figure out the value of M for letter A, it is going to be 14.5 inches. When we check our solution, we can see that balance is maintained in the original equation. For letter B, the measurement with the broken yardstick is going to be 31 5/8 inches. Again, checking our solution to make sure that we maintain balance. And finally, for letter C, the measurement with the broken yardstick is 9 3/8 inches, making sure that we check our work. Number 8 at the top of page 647 again is asking us to complete the table using our answers from questions 1 through 7. So go ahead and get all of the values filled into the table correctly for number 8. Here is what the table should look like for number 8, so carefully check over the values that you put in for each part of the table. At the bottom of page 647, number 9 tells us to use the table to complete the graph of actual measurement versus the measurement taken with the broken yardstick. So carefully take a look at everything that you filled in for the table in number 8 and plot the points on the graph in number 9. Here is what number 9 should look like when you take all of the values from the table and plot the points correctly on the graph. Finishing up with problem 1, take a look at number 10 on the top of page 648. Would it make sense to connect the points on this graph and make sure that you explain why or why not? Yes, it would make sense to connect the points on this graph because the numbers on the x-axis are representing measurements, and you can have decimal or fractional measurements. If we take a look at problem 2 on page 648, this again, much like with 9.4, is going to be your homework for today. You will have another problem situation that you have to read over, starting off with the table that you need to fill out, and then questions to answer that follow. I do want to tell you again for number 3 at the top of page 649, let's let D represent the distance in kilometers and T represent the time in hours, so that again we are all using the same variables for the problem. That is going to be it for lesson 9.5, using multiple representations to solve problems. Please let me know if you have any questions. Thank you.